Hello and welcome back. In this video, we're going to be finding the intervals for which our function is concave up or concave down, and we'll be identifying any inflection points as well. So all of this work starts with our second derivative. So our first derivative, which we need to get first, is 4x cubed plus 12x squared, and of course the derivative of 4 is 0. And then our second derivative is 12x squared plus 24 times x. And now we're going to be needing to find when the second derivative is undefined or equal to 0. And so we'll start off by first factoring it. And we could factor out a common 12x. Leaves us with x plus 2. So you notice by inspection, there's two values of x that make our second derivative equal to 0. We've got x equals 0, and we've got x equals negative 2. Now the next thing we want to do is put these on a number line. So we put negative 2 and 0 on a number line. And again, we are looking at the sign of the second derivative, f double prime of x. So if we take a value of x that is bigger than 0, such as 1, we get a positive second derivative because f double prime of 1 is equal to, looks like 36, which of course is greater than 0. And we could take something in between negative 2 and 0, which would be negative 1. Calculating that second derivative, we're going to get negative 12, which we know is less than 0. So our second derivative is negative on the interval. And then we need something smaller than negative 2, so let's take negative 3. And negative 3 is going to give us, it looks like negative 36. Actually, no, it's positive 36, right? Because we get a negative 1 from the second factor and a negative 36 from the first factor. So that's going to be positive 36, which we know is greater than 0. So we now have the sign of our second derivative determined, and now we can go ahead and answer the concavity. We know that since our second derivative is positive, we are concave up on this interval from negative infinity to negative 2. In between negative 2 and 0, we have a negative second derivative, so we know we are concave down. And then from 0 to infinity, positive second derivative, we are concave up again. So our answer to this question is going to be f of x is concave up on negative infinity to negative 2, union 0 to infinity, and f of x is concave down on the interval in between, which is from negative 2 to 0. And now we need to find inflection points. And to find those inflection points, we look at places where the concavity changes. And you'll notice at negative 2, we have concavity changing from concave up to concave down. So our inflection points are going to be those points or locations on the graph of the function where we have a change in concavity. So the first one is at negative 2. And we have to go back to the original function to get the value of y to complete our ordered pair. So negative 2 to the fourth is going to be 16. And then we're going to have negative 2 to the third power times 4. So negative 2 to the third power is negative 8 times 4. So it'll be negative 16 plus 4 is going to be negative 12. And our other ordered pair is going to be when we have concave down changing to concave up at 0. And if we plug 0 back into our original function, the y-coordinate is 4. So our two inflection points for this function are negative 2, negative 12, and 0, 4. And again, those are places on the graph where the concavity changes.